Hello and welcome to the Project 2 video for Calculus. If you haven't watched the video for Project 1 or it's been a while, you might want to go review that because we're going to use some of the same ideas we used there, just more so. So again, we've got GeoGebra open here, and we're going to go ahead and open the Project 2 file. So Project 2 Model Builder, this is available on Blackboard. You should go ahead and download it, make sure you have it. And when we open it up again, we're going to get our normal 3 windows, and we're going to move them around a little bit. So we've got our spreadsheet, our algebra window, and our main graphics window here. And again, the first thing we want to do is we want to go ahead and load our model into here. So just like last time, we're going to go to Edit and Insert an image from a file. And again, you should have downloaded your particular model for this problem. Again, that gives the power. And again, when we insert it, what's going to happen is we see right down here, this little line here, really hard to see is where to put our file. GeoGebra is not very smart. So what we need to do is we need to right click on this thing. So it might take a couple times. Make sure you see image, pick one when you right click. Go down to object properties. And again, what we're going to do is we're going to set up, by clicking on position, we're going to go ahead and set up our corners. So we're going to do lower left, lower right, and upper left corner. And what this does is this puts the image on our screen again. And this one you can see I played around a little bit before and it looks pretty good. Now in order to get yours to work, what you also want to do is you want to right click, go to object properties, and if you go over to color, what we can do is we can change the opacity. What we can do is we can change how transparent this image is. So if we put it 0, it disappears. But if we put it in pretty lightly here, I said around 50%, what we can now do is now we can see the axes and we can see the marks, the coordinates behind them. So we can get a better sense if we're lining up okay. And so again, we look at this, we see that 1,000 here on the y-axis corresponds to 1,000 on our graph. 500 and 500 are pretty close. Time 0 is here at 6 a.m. Time 2 is at 8 a.m. Time 4 is at 10 a.m. And it keeps on going down the line. And as always, if any of these look off, you can always just pick a point, sort of move it around until it looks pretty good. There, it looks pretty lined up. I would definitely try to get this, both your axes lined up pretty well, and it should work out pretty well for you. The next step is we want to put some dots on here so we can start building a model, our points. And so over in the spreadsheet, your spreadsheet will have filled out these. What I've done already is I put in, time 0, after a half an hour, after 1 hour. So 1 hour corresponds to 7 a.m., 2 hours probably 6 a.m. in your graph. And here I filled out some of my points. The heights I've gotten, the amount of power I've already generated. And what I've decided is that I'm going to build one graph starting from 0 all the way up to 4 a.m. From 0 to 4, I think that's one chunk of the graph. Probably another chunk of the graph maybe goes from like 4 to say 10, and then another graph on the other third part. So that's where I've decided to break it up. So what I'm going to do is I'm going to highlight just the times from 0 to 4, and I'm going to go ahead and do like I did before and go up on create list of points. It's going to create a list, going to be called list 1. And I'm going to create it. We can see that I did a pretty good job estimating these points. They land on my model pretty well. And now what I want to do is I want to try and fitting a polynomial on here. So the command I'm going to type here is a little different. I'm going to type if, and then in the box I want 0 less than or equal to x less than or equal to 4. And I'm going to fit a polynomial to list 1. And I'm just going to go for degree 2 polynomial to start. I don't really know what it's going to be, but we're going to start with 2. And so this curve, it looks, it's okay. It fits the model all right, but I think we can do better. So what I'm going to do is, like in the last one, I'm going to add this slider here. So if we click on this window up here, we click on slider, and we click down here somewhere. What I'm going to do is I'm going to build a new slider. Instead of number angle, what I want is I want an integer slider that goes from 1 to 30, and it's going to be called n. And now what I can do is I can go back over to my algebra window. I can double click on this function that I made, and I can replace the 2 in here with an n, hit OK, and now what I can do is I can move the slider back and forth, and this will change my model. So at 1, I've got a straight line, terrible model. 2, I've got a nice little parabola, getting better, cubic, quartic, quintic, 6, 7, 8, 9, 13. Well, once you get so high, it doesn't really change much anymore. So let's go back. And I'm kind of like a, I don't know, either 5, 6, I like 4. I think either 5 or 6 is pretty good. Let's go with 6. 6 looks pretty good. It mostly follows the blue curve behind there. You know, we lose some of the noise, some of the waviness, but overall I'd say it's a pretty good model. So over in the algebra window, I can see that this is the equation for my model right here. And if I go ahead and click on it and I hit the Command C or Control C, I'm going to copy that for later. And so what you can do is you can repeat this process for all the other model parts you build, you know. So from 4 up to 10, I would go over and highlight my data over here instead. You know, from 4 out to 10, I'd make my points. I'd make a slider. I'd type a very similar command down here, you know. Instead of, though, from 0 to 4, I'd go from 4 to 10. But again, I'd fit a polynomial to my new list of points, list 2, list 3, and I'd just keep building my models that way. Now, other things you're going to need to do, according to the project, is, first of all, what you want to do is you want to take the integral. And GeoGebra makes this really nice. What you do is you type int, and it'll pop up some options here. What we're going to do is we're going to use the third one here. We're going to take the integral of a function from a start value to an end value. So the function I want to integrate is f of x, and I want to go from 0 to 4. And f of x was the model here that we built using our polynomial. This was the function it figured out for us. And so if I hit enter here, what it does is that little a there, that tells me, that approximates the integral underneath there for me. And it even colors in the region so I can see what the integral looks like. So it says that from time 0 to 4m, I created 887 watt-hours of energy. So that's a good thing to know. And what this can use is this can help you approximate your graph later on. Now the other thing that you're going to want to do is you want to take the derivative of this graph. And for that, I actually suggest using a new window. So if we go up to File here, New Window, what I can do, and so what we can do is we can go over, if we click on our function, we can copy it, Control C, or Command C, depending on your computer. Come over here and paste it, Control V or Command V. And what it's going to do is it's going to copy over our function, we hit enter, and it draws the graph there, and we can see, okay, so it looks like our bounds are a little off here, so let's see. Let's go ahead and let's switch the ratio of the x-axis to the y-axis. Let's do 1 to 500. Ooh, that's a pretty good guess. Let's change the ratio actually to, say, 1 to 200. And if we click this little button over here, this will allow us to click and drag our window over it so we can take a look at it. And so this is our function it's drawn. And what we can actually do here instead, too, is now we can also take the derivative. So we say derivative, because that's a good thing to name the function. And we take the derivative of f of x, and it graphs this for us there as well. So I made this new function g, which is the derivative. And it'll actually graph the derivative there for us as well. And I think it'll even, if we zoom on out, it even stops it right at 4. It's a pretty smart little tool here. And click the little arrow. Let's move this up again. And let's go ahead and color them because I like color. So let's see if I click on this one. Object properties, I can go ahead and make that one. Let's make the derivative red so it stands out. Okay, so this red graph is the graph of my derivative, and the black one's my original one. And I can keep repeating this and make a nice graph for all my functions. And so this is the basic thing. What we're going to do is we're going to repeat this basic process for each other section of the graph. So we have another section of graph maybe here. We plot the points, we build the model, we take the integral and derivative, and we do it for the third part as well. We put all our derivatives in a nice graph together here, print it out, make sure everything's labeled and it looks nice, and we'll be good to go. I went through this kind of quick. If you have any questions, of course, you can always stop by or see me during office hours or ask in class. Have a good day. Bye.